All right, welcome to Trig class. A lot of you transitioned from my stats class into this. Trig's a little bit different than what we did with stats. We'll have more bookwork here in Trig class than we did in stats. Stats is a little bit more worksheet oriented. But our book here, even though it is archaic, some of your parents may have used it if you went to school here. It's still efficient, and it does what we need to do in regard to Trig class. Some guidelines, how grades are done in Trig class. 90% of your grade is determined by the quiz, 10% of the grade is determined by your in-class assignments or your homework. I will not collect homework. I don't check homework. Homework is practice for you. That's my philosophy. Homework is practice for you, just like if you're a part of the drama productions, you're part of musical, the band, marching bands, if you're part of the sports teams, you go through practice. Practice is for you to get better at what you're doing. What I will do is I will do what is called in-class assignments. We'll come in, we'll go over a problem or two if we need to in regards to your homework. Then at that point, if you didn't have any questions, I'll have an in-class assignment, which will basically be the same type of problems that you saw in your homework. So they should be something that's fairly quick to be able to get through if you've done your homework. I will grade those. Those are ones I will collect. That's a way of me checking to see if you've been completing your homework. Quizzes 90% of your grade. You have one every week. Week to 10 days, you'll have a quiz in here. Each quiz worth 100 points. Your homework, in-class assignments. Homework is practice for doing specific mathematical skills. Students are strongly encouraged to complete their homework assignments. In-class assignments will be given. They'll all be worth just 10 points apiece. They make a little impact in your grade. Basically, your in-class assignments impact your grade if you're a borderline between an A and an A minus, or a B and a B plus, or a B plus and an A minus. If you're a borderline there, it'll make a difference in that in regards to that. That's the impact that in-class assignments will have in your grade. What it should do, though, is it is a check, a self-evaluation check for you to see how are you handling the types of problems that we are going through in this classroom independently. You're not asked for help. You're not asking for help from somebody else. How am I handling the material by myself? Hopefully, you will do well with them. That will give you confidence that you're able to have success on the test. Your quiz average will be multiplied by 9%. Your in-class assignment average will be multiplied by 10%. These two values are added together. It's called a weighted grading scale. Dealing with the quizzes, those are with how I do grades. It's a weighted grading scale. Each 9-week grading period, the student's lowest quiz grade will not be averaged into the final 9-week grades. I will drop your lowest quiz grade every 9 weeks. You have your semester and final grades. This is a semester course, so we have to have a final. So we will have a final at the end of the year over Trig. Makeup policy, all notes, homework, worksheets, review sheets will be posted on, I used to have Progress Book, now will be on Classroom, Google Classroom. Everything's posted on there. Solutions to worksheets will be there. Notes that we do here in class will be there. Everything will be on Classroom. All you have to do is go to Classroom. If you're absent for a day and you want to know what we're doing that day, I post it as quickly as I can after the class period. I will post the notes. The homework is there. Everything is there for you. So you don't have to come ask me, what did we do yesterday, Mr. Gregory? Go to Classroom. Everything is there. You can click print. You can print the notes off that we did here in class. So everything is on Classroom. All work while the student's absent is required to complete and turn in as follows. If you're sick, these days we're sick, and we have people in and out all the time. Get to me as quickly as possible and get some time where you can make up your work that you have to make up. Makeup quizzes will be done on your time. I'm not going to set you out in the hallway and say, hey, take the quiz while we're having class here. Okay, you can find a study hall. You can be in here before school, after school. Anytime that you can come in here and complete, that's when you should do it. Don't come and ask me, when do you want me to do this? I don't know your schedule. You know your schedule. So you find a time and just saying, I will come in, Mr. Gregory, I'll be here at such period to be able to take the quiz. Okay, that's fine. If we have a class going on, it's not a big deal. Okay, we have room in here. We can set you down. You can do your quiz. In-class assignments missed. You have next day to complete. Please get it done. Students' responsibility to take makeup work. Notes from the teacher or fellow students, or once again, classroom. Your responsibility. Students missing class or prearranged activities. We have a speech contest coming up here at the end of January. If we have a quiz on that day, what my suggestion is, come tell me that I'm going to be out that day. I'm going to be gone that day. Come in before you leave on that day to take the quiz. Okay, or if you have any other prearranged activity that's going on, you know you're going to be gone out of the class, come talk to me and say, I'm going to be gone that day. When do you want me to make up the quiz? And I'll give you maybe some suggestions when we can take care of your responsibilities. My suggestion is, especially if you're going to be gone an entire day, come in before school here and just get it done before you leave. Rules and regulations. If you're late, please get a pass. Bring all your books and paper. Bring everything with you. Calculators. You can get by with a standard calculator in this class, but most of you, I think, are in the tune of your graphic calculators. That is fine. There's some advantage to it. If you have a basic scientific calculator that does your sine, cosine, tangent, you'll be able to survive in this class. It'll just be a little bit more work for you. If you have a graphic one, it's obviously going to be a little bit easier for you because there's certain things that we will go through that will help you and assist you in the class. 3-ring binders. Most of you have had me in the class already. Please make sure you get your 3-ring binders. If you have not been in this class before, get a 3-ring binder. All your notes, and you'll see it today, I will hand out your notes to you. This sheet is 3-hole punched. Everything can go in there. It's a way of keeping yourself organized. It's a tool and technique that you can use as you go throughout your high school career and also your college career to help organize yourself and keep yourself better organized. Having a 3-hole punch, which some of mine just walked away. Having a 3-hole punch when you go to college, and 3-ring binders, those are great ways, once again, just to continue to organize yourself. Who stole my 3-hole punch? Thieves. Is there a TikTok thing? Take something from your teacher day or something like that? Non-compliance with rules and regulations in this classroom, I will take care of it and I will deal with it. Tips for being successful in this class: be in class, be here. Missing one day is like missing 2 days. Okay, so keep yourself healthy. Take effective notes. Make sure you include examples done in class. Participate, ask questions in class. There exist no stupid questions. When doing your homework, use your notes and examples in the book. You never know when a problem you're stuck on may be done as an example. If you're still stuck in a problem, I'm here before school. Stop in before school and ask me a quick question. That is fine. Use review sheets as practice tests. If you don't know how to do a problem on a review sheet, you won't know how to do the problem on the test. There's not a magic force field when you sit down at the test and say, oh, I know how to do this now. Keep all your tests and quizzes. All questions for the final are identical to the questions on tests and quizzes. Just gave a final in my trig class first semester. Let's go back to my old quizzes that we took through the year or through the semester and just take problems off of there and turning into a multiple choice question. Once again, things that you need for this class, need a calculator, 3-ring binder. If you can get a 6-inch ruler, some sort of straight edge, that is fine. You can make your Mr. Wizard straight edge if you want by taking a piece of paper, folding it in half, and folding it in half again. You can make a straight edge here, here, too. There you go, nice little straight edge that you have that you can also use as a bookmark, or buy yourself a 6-inch ruler. They may cost you 20 cents or 25 cents to be able to pick one up. They're nice things to have. Once again, you can use a bookmark as you advance in your mathematical careers. It's important to, if you're making straight lines, you use a straight edge. Straight lines are made with straight edges. If you are freehanding graphs and you're just doing an XY axis and you're freehanding them, I will count points off if you just freehand the graphs. So make sure you're using straight edges to be able to get your graphs. Any type of straight lines need to be done with a straight edge. Questions you have? Expectations. I have expectations of class. We're here for a job. We're here to be educated in trigonometry in this class. You have a responsibility. I have a responsibility. We need to take care, both of us need to take care of our responsibilities. It is a little bit faster pace class. You need to keep up with the material. And once again, most of you have been through some of my classes. You know what my expectations are. Trigonometry. When you're in geometry, you had a section that dealt with sine, cosine, tangent. When you were in geometry, and you dealt with some right triangle ideas. Okay, this class expands on those ideas and looks at all different types of aspects in regards to sine, cosines, and tangents, trigonometric functions. By the way, I'm a morning person also. So those that haven't been in here yet, I'm a morning person. I like to get things going in the morning. So if you're not a morning person, this might be a rough thing for you. I like to get things going. The first section that we will go through here in regards to trig, it has absolutely nothing to do with sine, cosine, and tangents. Has a lot to do with what you learned back in the algebra classes in regards to coordinate planes, ordered pairs, functions, relations, things of that sort. So it has nothing to do with trig. Next week when we get through this first section, we'll start talking about the idea of trigonometric things. But just a nice way to get us started, because all this stuff should be familiar with you, or to you, in regards to information that you have seen. When you talk about a coordinate plane, coordinate planes are two-dimensional number lines. When we deal with a coordinate plane, we talk about two-dimensional number lines. Coordinate plane, you have two-dimensional number lines. You have a vertical number line, you have a horizontal number line. We have vertical number lines, we have horizontal number lines. This is what is meant by two-dimensional number lines. These number lines, what do we call these number lines? Axes. That's correct. We have axes. Now, we have a vertical one, we have a horizontal one. What do we call the vertical one, Ella? Which axis is the vertical one? The y-axis. And the horizontal one? The x-axis. We have the x-axis, we have the y-axis. Typically, we don't put the word axis in there. We just label them x and y. So we have the two axes. These two axes intersect at one point. What do we call that point where they intersect? The origin, that is correct. So we have the origin. The origin where the two lines intersect, the two number lines intersect. And once again, there should be nothing oohing and on you. You should be very comfortable with this material. We have the number lines that take our plane. When we talk about a plane is a flat surface. The surface of this floor is a plane. The surface of the walls are planes. It is a flat surface. The smartboard here, the surface of the smartboard is a flat surface, so that is a plane. The x and y axis will go on indefinitely. These are lines. They are lines, so they will go on indefinitely to the left and right, up and down. We divide our plane into 4 regions. What do we call those 4 regions? What do we call the 4 regions? We have a specific name for the 4 regions. Quadrants, that's correct. We call them quadrants. What is quadrant number 1? Do you remember? Okay, we have quadrants. What's quadrant 1, Jake?
Top right.
Top right. So we label this with a Roman numeral. We have quadrant number 1 in the upper right, the positive quadrant. Which direction do we go? Ethan? Huh?
Left.
Yeah, we go counterclockwise or left. So we have quadrant number 2, quadrant number 3, and quadrant number 4. Those are the different regions. We will have problems as we go out the entire trig class where you will need to know this information. Which quadrant does an angle terminate in? We will have angles of rotations. So we will look at quadrants where we terminate an angle. We take a look at an ordered pair. An ordered pair indicates a position on a coordinate plane. An ordered pair indicates a position on a coordinate plane. Ordered pair indicates a position on a coordinate plane. And when we're talking about an ordered pair, the x value will come first, the y value comes second. It's the horizontal axis variable will come first. The vertical axis variable will come second. When we talk about a graph, it's a picture that represents an equation. It's a picture that represents an equation. When you talk about a graph, when you graph something, you've gone through many algebraic classes that talks about graphing equations, and we have the idea where we have a slope-intercept and we graph an equation. But what I want you to also remember is an alternate definition to what a graph is. if I had the equation x plus 3 is equal to 7, and I ask you to solve that equation. Vanessa, how would you solve that equation? X plus 3 is equal to 7.
Subtract 7. Subtract 3 from 7.
Yeah, subtract 3 from both sides. Minus 3, minus 3. So we come down to x is equal to a value of 4. When we solve equations, we are looking for values that I can put in here. I can put 4 in here and say 4 plus 3 is equal to 7 to make a true statement. My value of 4 makes that equation true, makes it a true statement. If I said x was equal to 1, I would not have a true statement there. 1 plus 3 is not equal to 7. Solve that equation. Y equals x plus 1. Solve that equation. Well, when I had just one variable there, x plus 3 is equal to 7, I asked you to solve that equation, but that's what was very quick to say. I subtract 3 from both sides, I get x equals 4. I solved the equation. But what if I said y is equal to x plus 1? Solve that equation. Well, if I subtract 1 from both sides, I have x is equal to y minus 1, but I don't get a value. I don't get a value. But can we come up with values for x and y? What two values would make this equation true? What ordered pair, what value of x, what value of y would make this equation true? 1. If x is equal to 1, what would y equal?
Oh, 2. Sorry, or 1, 2.
Pick one. Which one?
1, 2.
1, 2. If I said x is equal to 1, y is equal to 2, would that make the equation true? Yeah, it would. Which we can put into an ordered pair 1, 2. Is that the only values of x and y that would work? Ethan Farnsworth, any other values? 2 and 3. X is equal to 2. Y is equal to 3. That would make the equation true. Maddie West, any others? 4 and 5. Is that x is 4? Y is equal to 5. That would make the equation true. And this would give me the ordered pair 4, 5. Now, are there only 3 values? No, we have an infinite number of values. Well, let's take a look. What we have created here is we have created some ordered pairs. If x is 1, y is 2. If x is 2, y is 3. If x is 4, y is 5. Well, if I take a look at these 3 ordered pairs, what we form is we start to form what is called a line. And if I would take my straight edge and connect the dots, la, la, la. We draw a line. In geometry, you talked about lines. how many points exist on a line? Ash, how many points exist on the line? An infinite number of points. That's what you learned in geometry. Infinite number of points. So we have 3 of them there, but we have all these points right here. All these points right here. Every one of those points is a location or a position on a coordinate plane, which means if it's a position on the coordinate plane, we have an infinite number of ordered pairs. Well, what's going to be special about those infinite number of ordered pairs? Each one of those ordered pairs should make this equation true. So if I ask you, and this is every math teacher and every problems that we do that deal with graphing, we give you directions as a math teacher, graph this equation, graph this equation. What we should be saying is we should be saying, solve this equation. Because the solution to this equation is this graph. That's the solution to your equation. So a graph is a picture representing an equation. Really what it is, it's a solution It's a solution set to an equation in 2 variables. It's a solution set to the equation in 2 variables. I ask you to solve y equals x plus 1. Well, we just can't come down to one solution. Like we did y or x plus 3 is equal to 7. I came down to one solution. We can't come down to just one solution with y equals x plus 1. Why? Because there's an infinite number of solutions. Well, how do I represent an infinite number of solutions? I do it with a graph. Bless you. Because with that graph, it represents an infinite number of ordered pairs. And each one of those ordered pairs will make this equation true. A graph is a solution to a variable and 2 equations, or an equation with 2 variables. Well, we have special types of things, and we can classify our equations. The first one is a relation, which is just a set of ordered pairs. A set of ordered pairs. Told you I'm a morning person. How do we represent a set? We use what is called braces. What is a brace? It's not going to the orthodontist, Dr. Grimm over there in Worcester, and getting your braces, or Dr. Pooler. I heard they retired. Did they retire? Anybody getting braces over there anymore? Dr. Grimm and Dr. Pooler over in Worcester Orthodontics. Braces. It is a curve to a point to another curve. That's a brace. You want to think about it in the drama world? We have our comedy tragedy. So it looks like that. Representative, we have a set. We will do the traditional ordered pairs. We have 3 ordered pairs there. The braces signify that we have a set. So we have a set of ordered pairs, 1, 2, 3, 4, 5, 6. Once again, we have to signify that we have a set. We signify with a brace, and we have to state set of ordered pairs. What do we have here? 1, 2, 3, 4, 5, 6. The domain. It's the set of all first values of the ordered pairs of a relation. the set of all first values of the ordered pairs of a relation. That is your domain. What I want you to do is write down your domain next. I have the ordered pairs 1, 2, 3, 4, 5, 6 up there. Set of all first values of the ordered pairs of the relation. What is the domain? Those who have not been in my class, we do these guided notes. Notes are done with these guided notes daily. And we have notes. Once again, nice to have the 3-ring binder. Put it in the 3-ring binder so you can keep yourself organized and find the notes that you need to find. Those that were in stats, you can clear out your stats one and just reutilize, repurpose it. What is our domain? Grayson, what's our domain here? 1, 3, 5. Not correct. What did we forget? Which means what? What's the braces mean? The set of 1, 3, and 5. Now that is correct. Or 1, 3, and what should it be? 1, 3, and 4. There we go. The set of 1, 3, and 4. Because those are my first values. 1, 3, and 4. The range is a set of all second values. The set of all second values of the ordered pairs of a relation. Write down your range. The set of all second values. Come back to you.
Brace and then 2, 4.
Okay, set of values 2, 4, and 5. A function is a special type of relation. A function is a relation such that each values in the domain correspond to exactly one value in the range. A function is a relation such that each value in the domain correspond to exactly one value in the range. We take a look at 2 examples here. We want to indicate if they're functions or not are functions. We have 3, 4, 7, 4, 8, 2. What I also like to do in regards to grouping these is do what I call as amoebogram, an amoebogram. Here's my domain amoeba. Here's my range amoeba. They sort of act as your braces. In my domain amoeba, I'm going to put my domains. In my range amoeba, I'm going to put my range. Now, we don't want to recopy. If we already have something there, we don't have to put it in a second time. In my domain amoeba, we have 3, 7, and 8. In my range amoeba, I have 4. I have another 4, and I have 2. So we only have to put the 4 and the 2. A relation a function is a relation such that each value from the domain corresponds to exactly one value in the range. The word corresponds. How do we indicate what corresponds to what? Well, if I have the value of 3 in my domain, what do we think that corresponds to in the range? Melanie, what do you think? 3 would correspond to what? 4. Now, why would you say that? Yeah, they're together in the ordered pair. 3 corresponds to 4. 7 corresponds to 4. 8 corresponds to 2. Is this a function? A relation such that each value in the domain corresponds to exactly one value in the range. Is this going to be a function, Lucas?
No.
Why not?
Because the 3 and 7 correspond to the same range.
Okay. Corresponds to exactly one value in the range. So 3 corresponds to how many values? 7 corresponds to how many values?
1.
8 corresponds to how many values? Does each value in the domain correspond to exactly one value in the range? Yes, so this is a function. We have our domain amoeba, we have our range amoeba here. In my domain amoeba, we have 3, we have 7, and we have 3 again. So we have 3 and 7. My range amoeba, we have 4, 8, and 2. Three corresponds to 4. 7 corresponds to 8. And then 3 corresponds to 2. Is this going to be a function? No, because each value in the domain doesn't correspond to exactly one value. 3 corresponds to 4, but 3 corresponds to 2. 2 different values. So this is not a function. Okay, what you're going to be doing in your homework for today, we got a couple minutes here. What you'll be doing in the homework's page 5 and 6, 1 to 13, the odds. That's also on Classroom. Okay, the day, what we have up there is also what is going to be assigned. What you'll be given an equation, and you're going to be given a domain. You're going to determine an ordered pairs and get a graph down. Here's our domain. We have X, we have Y, 2, 3, 4, 5, and 6. Here's our equation. You're substituting in X and solving for Y. So we have 3 times 2 minus 5, which is a value of 1. Then we have 3 times 3 minus 5. So we have 9 minus 5, which is 4. Then we have 3 times 4 minus 5. 12 minus 5 is 7. Then we will have 10 and 13. Each one of these will give us an ordered pair. Once you get your ordered pairs, we go to our graph. And we graph our ordered pairs. my numbers get big. I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14. And then put a little hash in there. And we graph our ordered pairs. X is 2, Y is 1. X is 3, Y is 4. X is 4, Y is 7. X is 5, Y is 10. And 13, 6 and 13. And you want to get a graph down. Tomorrow we'll go on the back side of our notes and we'll describe the graphs, what types of graphs we have. We'll also take a look at your calculator. We'll have a little KYC opportunity, know your calculator, because your calculator will do some nice things for you. So what you have for homework tonight is page 5 and 6, 1 to 13, the weird ones, the odd ones. Tomorrow we'll finish the notes and we'll go look at your calculator and look at any problems. We'll spend a couple days in this section doing some graphs. Questions you have? Yeah, that's all, folks. That's done.